What's going on, folks? Actually, it's just Kalena and Victor hanging out today. We're going to start up on talking a little bit about Chapter 20. I won't get into capacitors because what I did was I actually put up a lot of your homework. And granted that I put up a whole lot of your homework, and Victor's telling me that it's getting a little stressful because there's a lot of stuff due. But at the same time, if you really think about it, like, I gave you this homework and it was supposed to be due like 2 weeks ago. And so you should have technically done it then. I could have just made it the due date and then it's just kind of like a place for you to put it. I'm assuming you didn't do any homework that I assigned because I didn't put up any drop boxes, and so it didn't seem very important to me. And it is important to me that you get practice with this. Now, you guys are freaking out because you guys are thinking yourselves like, oh wait, does that mean for this grade check that's coming up on Friday I'm going to get burned because you assigned all this homework? Yeah, this is actually the major grade check. This is the one in the middle of the semester. So this is the one that's going to be sent back to your parents. And I'll tell you this. Here, ready? Do your homework. That's important. I'm not going to burn you. I'm not going to give you an F or a D to get you on your, so you guys can have on your report card, whatever. That would suck of me. But I still want you to do your homework, right? Because I want you to get practice with this. The only way you're going to get good with this level of stuff, this math-based stuff, is to do your homework. And then, by the way, just to let you know, Kalena, what do you think of the STEM class? The one we do on Fridays. What do you think of that? Awesome. I don't get a response from you. What do you, come on, I'm talking to you. Anyway, well, I guess I'll talk about the STEM class later when you can hear me, or I can talk back to you. All right. So I'm covering. I'm going to talk to you about Chapter 20, page 701, because everything else was covered before that. So let's do that. Electricity, electric potential energy. We're talking about Chapter 20, page 701. It's right here. Awesome. So we're going to talk about equal potential forces, and basically it's a really easy concept. Okay. You know how we draw electric field lines? We talk about a charge going from the positive into the negative, and we talk about how the electric field line is a positive charge going towards the negative, and then I introduced it to you using that idea of a contour map. Well, it's kind of, when we talk about equal potential surfaces, think about this. If we have a negative charge right here, right? How would the electric field lines look? Well, it would kind of look like this. Or you know what? Let's not talk about a negative charge or whatever. Let's talk about a mountain. Okay? I'm going to draw the side view of a mountain. Let's say a mountain looks like this. Okay? Its highest point is in the middle. There's some trees over here. And there's snow on top. That's a mountain. Can you see it? And then when we do a bird's eye view, it would kind of look like this. And then maybe over here it gets... Are we cool? Can you see the mountain when I draw it in the bird's eye view?
Yes.
Kalena, you good? Can you see the mountain? This is the same picture. I'm just looking at one from the side and one from the top, from an airplane. We cool? Now, if I were to walk along this line over here, if I were an ant and I were crawling along this line, or a person or whatever, and I were walking along that line, as long as I was staying on that line, what can you tell me?
You're not changing elevation.
Yeah, I'm at the same height. I'm not going to go up or down. I'm basically, if I walk this way, then I change my elevation, right? And in fact, if I walk completely perpendicular to those contour lines, I'll change my elevation the fastest, right? Because I could walk this way.
Assuming we have a perfect mountain.
What do you mean, assuming we have a perfect mountain?
Because the mountain doesn't always have perfect slopes.
Oh, yeah. We're talking about a nice, uniform, straight mountain, which actually doesn't exist, of course, right? And it'd be easy. It's probably easier to walk up a mountain in a spiral. That's why you see people going up a mountain in a spiral, because if you want to go straight up, usually that involves rock climbing.
Yeah.
And that can tend to be tougher. But if you want to go up a mountain, you would go switchback trails, and you go around the mountain, up the spiral, that kind of stuff. But, yeah, you see what I mean. Like, let's pretend that this is just like a straight up mountain. You know what I mean? There's no rock climbing required. It's just a big grass hill that comes to a point at the top.
And there's snow.
We cool? And there's snow on top. Yeah, no rocks, nothing. That's it. All right. So what we call this is, like, I don't know if there's a word for this, but this would be equal altitude lines. And that means that, like, this on that line right there, you would be at an equal altitude, right? So we have this thing called an equal potential lines when we talk about when we talk about, like, charges. And let's assume that we have, like, a positive charge. Okay? There's a positive charge. Then a test charge would go which way? Test charges are positive, by the way.
Oh, sorry.
It would go away, right?
Away.
So there's this potential that we have set up over here, right?
Yeah.
But a test charge over here
Same distance would have the same potential.
would have the same potential. So it would be the same potential all the way around. So wherever you are, as long as you're standing somewhere on this circle, assuming I drew a nice pretty circle, this is an equal potential. It's exactly the same analogy as when we had the contour lines. If you walk along that thing, or wherever you place your test charge over there, it will have the same potential across. We cool? So that's all we're doing. We're pretty much all we're doing is I introduce you to the concept of these little contour lines, but actually that's all we're doing is we're adding contour lines to our graphs. So, like, let's talk about, like, here's another example. Say I have you know what we'll do is, say that I have a positive test charge over here and another positive test charge over here.
Okay.
How would
They're both test charges.
those, or no, they're both charges, not test charges. They're just regular charges. How would the field lines look?
How did that?
Well, if you put a test charge right here, he's going to go which way?
Oh yeah, it's gonna go down.
Kind of going to go down like that, right? If you put a test charge right here, he's kind of going to go down like that.
Just really tight.
Like that.
Why does it curve? Over there. Why does it curve?
Why does it curve when you
Yeah.
get towards the back over here?
Yeah.
Well, it wouldn't go if this were the only charge over here, then it would go straight out. But there is still a little bit of effect from this guy over here.
Okay.
So if you're straight behind there, then this guy will go away, right? But if you're off a little bit, it won't go straight out because this guy is still pushing him a little bit that way.
Okay.
So it would curve. I like your question though. And then this guy would curve down like this. And it would kind of look like this. Are we cool?
Yep.
Alright, but now let's draw the contour lines. Like, where do they have equal potentials? And we know that, let's do it in red. We know that it would be here. But where else? It would be here. And then, like, over here kind of has an equal potential. I'll show you how the graph kind of goes. It goes here, and then like this a little bit. And then when it gets big enough to encircle both of them, it's going to kind of look like that.
It's basically they add up the charges and figure out which positions gives.
Well, I mean, think about this. Like, think about this. If I were to compare this to a mountain, then the side view of that mountain would look like this. Do you agree?
Yeah.
So if it's negative, if these were negative charges, I would make a dip.
Okay.
But since they're positive charges, I make these little mountains, because I was thinking about it like a marble rolling around on these hills, and it's hard for the marble to get up. The marble would want to go away from the thing, whereas if it were a dip, the marble would want to go into that thing. It would be attracted to that. So since they're both positive, wouldn't you agree that these are the same contour maps?
Yeah.
Like this is just the contour map of that mountain. We cool? So that's pretty much what happens.
Okay.
We good?
So there's an infinite amount of like lines we can draw.
Yeah, you can draw as many lines as you want, but you probably don't want too many lines because it's like it'll just clutter up the picture. We cool? All right. So I'll tell you what. Here's what I'm going to do now. I'm going to switch it up, and I'm going to show you what happened in our classroom. I went through and I fixed our class. I didn't have the drop boxes up. I kind of sucked at that. I fixed the STEM class and I fixed the electricity class. And I put up the drop boxes from the homework assignments that we had due, and I assigned these like a month ago.
Yeah.
Or like a couple weeks ago or whatever.
Still chapter 19.
They're all from chapter 19. I didn't even assign chapter 20 stuff yet because we're still in chapter 20. So I don't think it would be fair for us to cover chapter 20 homework. I mean, technically, I guess we should, but I figured, hey, you got enough chapter 19 stuff to worry about, right? And actually, if you look at the plan, like today is what?
So you updated the plan too?
The plan is updated as well.
Okay. So when's everything due then?
Well, I wanted to have stuff due. I wanted to have chapter 19 stuff due before I had your grade checks in, but I'm thinking obviously I'm going to have to push that back because technically the first 2 pages of chapter 19 is due today. Our first 2 homework assignments for chapter 19 is due today, and then the next 2 are chapter 19 and homework assignments are due tomorrow. That's not really fair, since I only really fixed it on Monday.
It's not that bad, actually. It's like,
Does that make sense? Or is that? Do you guys agree with that? Like, I hope you guys would have started working on it, but I mean, I understand if you guys haven't, because that's not necessarily fair. So what I'm going to do is I want us to do the homework, because I feel like the homework is going to help us get it. But I'll tell you what I'll do is, why don't we sit and do it together? Why don't we kind of like talk about this stuff and go through this stuff together? Sound good? So I'll do a couple problems from each of these so that you guys can get your feet wet. And maybe what we'll do is I'll do maybe the first 3 assignments with you guys, but I'll do 1 or 2 problems from each of those things. Sound good? So grab your pencil, grab your paper, let's start, just pull it out and start working on it. Because I think it's important that you do homework, because I think that you should have practice with this stuff. But I also don't want to assign so much homework that I just burn you on this. You got it? Kalena? I'm wondering where my class is. But anyway, let's pull up chapter 19 and see what we got. I'll be spending time with you. Alright, let's see. Chapter 19, I'm on page, well, wherever the homework is, which it seems like it starts on page 682. So the plan is, says 683 number 5 and 12 and 684 number 17.
63?
Why don't we do number 17?
Oh, what page? 64?
684 number 17. We'll talk about it together. Sound good?
Okay.
Alright, you ready? What is the separation of the electrostatic force between a positive 11.2 microcoulombs point charge and a positive 29.1 microcoulombs point charge, equal in magnitude to 1.57 newtons? So they're saying this.
Using that equation, right?
Number 17. This was from, if you look up from where the thing is, it says that we're covering Coulomb's law. right?
Yeah.
Coulomb's law was F equals K Q1 Q2 over R squared. Cool? And you wrote N, but it's F. It's measured in newtons, that's units, but the force is F. And they told us Q1 was what? Do I have? I didn't write it down. What is it? 11 point?
I didn't see those too small too fast.
Alright, fine, here. I'll just put it up over here.
7.
No, I have them all. Okay, 11.2 microcoulombs. So Q1 is equal to 11.2 microcoulombs, or
Micro wrong.
11.2 times 10 to the negative 6 coulombs. What?
I wrote micro wrong.
Micro is the little mu looking thing.
Yeah. I just wrote the long 10 on the wrong side.
Alright. Q2, on the other hand, is 11 point, or no, is,
These are both positive? Or
they're both positive. 29.1 times 10 to the negative 6 coulombs. And they're both positive. Positive, positive. So, my question is, what is R?
just solve R, right? Just plug it over.
Pretty much you just take this thing and you solve it for R. You have F, you have K, you have Q1, you have Q2, you just want R. Kalena, do you know how to do that? Kalena? Sort of. I'll tell you what, why don't we do this? Let's do another problem.
Okay.
What is 5 times 3 times 2 times 1, we'll make it 4, divided by x squared? And I don't want you to multiply anything out.
Oh, okay.
So what do I do?
You move the x squared over.
I'll move the x squared over because I don't like solving for things when they're in the denominator.
There, it's ugly.
Right.
Especially when you have a square.
I don't even know how to solve things when they're in the denominator. So I'll say 5x squared equals 3 times 2 times 4. And why do I just dump that into the numerator? It's because essentially, okay,
Multiplying it.
yeah, because essentially I multiply both sides by x squared.
Yeah.
Cool. All right. Now, how do I get the? I want the x all by itself, folks.
Dump the 5.
Dump the 5 by doing what? By dividing. Exactly, Kalena.
I just say dump the 5. It's easy.
Don't worry about multiplying those out yet. Just deal with what we got here. What about the x?
Dump the square.
How do I dump the square?
It's SQRT RT.
I squirt it.
Squirt.
Well, that's what you said. So it's equal to 3 times 2 times 4 over 5 square root.
I like that word. You squirt it.
Yeah, and I just made it up now. All right, yeah. Essentially, Kalena, you're doing the exact same thing. You know what F is, you know what K is, you know what Q1, and you know what Q2 is. You just want to find R. We did this. We solved it already. That's exactly it. In fact, I'll tell it to you. R is equal to the square root of F K Q1 Q2. No. K Q1 Q2 over F. I mean, you should go through the process. You should multiply both sides by R squared. You should divide by F. You should take the square root of it. And then you have R is equal to blah, 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 blah. We good?
Yeah.
What's going on?
Hi.
They're out to lunch with you?
Well, they just wanted to go home.
Oh.
And do their work. Are they cool to go home?
It's up to you. Their chapter 3 homework is due today. I was going to plan on hanging out with them and finishing off chapter 3 with them, making sure they get it in. Because their chapter 3 is actually
Come here.
all due tomorrow.
Sorry.
Oh.
Alright, hey, I'm sorry. I'm talking to a parent, you guys. I'll let you guys
Do we
think
know
about this stuff.
I see the homework. The problem.
The problem is here.
What? So what?
Oh, yes, I'm sorry. Force is equal to what?
Yeah, force is equal to 1.57.
1.57 newtons. So, I don't know. Just plug it in at this point. Alright, I'm going to hang out with you for just a second. What's up?
The only reason is something really freaky just happened.
Okay.
I was getting their lunch on Keomoku Street.
Yeah.
And I'm standing outside waiting for the lunch, and then Keomoku Street now, this car drives by, and I see them like open the door and like throw some. It's a little kitten. They threw it in the middle of the road.
That's terrible.
So I ran in the middle of the road. I'm like, stop, stop. And I have a little kitten in the car. Little.
Wow.
Unbelievable.
All right, so actually I'm in class right now, but what I'm going to do is, if you want to leave them here, I can pretty much babysit them and make sure that they're done with their homework. If you want to bring them home, they have to do their homework on their own.
Can
They
you do
they
it?
could be big kids. You guys got your big boy pants on,
Yeah.
so you guys can go and do your homework on your own. But if you feel like they need that, they
What do
need
you, what do
me
you feel
to have an
today?
eagle eye on them.
No, what do you feel? It's
And then-
all on you.
And then what I'll do is, I'll tell you whether or not they turn in their stuff, and then we can say whether or not we need to like switch them back to Pampers, or do we need to you can keep your big boy pants on,
Training pants on.
right? So
Yes,
Yeah.
archive. You
We-
get to
we
see all this
cool?
drama.
Yeah.
yes, archive.
Okay?
I'm in
Tell
electricity
them
class
you
right
won't
now.
disappoint.
All right,
Okay?
you guys going home? All right. You might want to check with other teachers too, just kind of like see where they're at.
Alright.
All right.
Thank you.
So
See you all the time.
so what? How was that homework
I
problem?
feel like I'm good. I don't think I'm good.
Oh wait, we didn't solve the problem,
We
right?
didn't solve it yet, no.
All right. So r is equal to the square root of what is k? It's like 8 times 10 to the 8.
8.99.
Oh, no,
it's 10 to the
9 times 10 to the 9.
8.9. I don't know.
8.9. Whatever. 9.
Okay.
9.
I'm sorry.
Plus, I'm just rounding it off. I don't even. Times 10 to the negative 6. 29 times 10 to the negative 6. Divided by f, which is 1.57. We cool?
Yep.
All right. Deal with the numbers. What's 9 times 11 times 29 divided by 1.57? I have no idea, so I'm going to look it up. Let's do it on this tab over here. 9 times 11 times 29 divided by 1.57.
Ryan calculated this one.
1828.
1828.
1828. I'm rounding. Alright. Times 10 to the what? 9, negative 6. Negative 6. You guys know how to do that?
Just combine all of them.
That's just negative 3.
Yeah.
Kalena, do you know how I got the times 10 to the negative 3? This is scientific notation, girl. You in chemistry now? Then you should be learning scientific notation. All I'm doing is, what is times 10 to the 9 times 10 to the negative 6 times 10 to the negative 6? When you have the same base, different exponents, you add up those exponents. You understand that rule, right?
That's 29.3.
What?
I didn't divide by 1.57.
Oh, divide by 1.57, dude.
God, I like showing my work.
Alright. I know scientific notation, but I need help multiplying and dividing them. Oh. Well, that's what you do. That's all you do.
You just subtract them all. That's what an exponent rules.
Yeah. Yeah, there's just exponent rules. It's like this. What is x cubed times x squared? Kalena, all it is this. X cubed is x times x times x, right? X squared is x times x, and if you put a times in between there, that's really just x to the 5th power. The easier way, obviously, to do that would be, hey, it's the same base, different exponent. I just multiply them out.
Yep.
But what if I have like x cubed times x to the negative 5? Let's try that. Well, if I write it out the long way, it would be x divided by x. The top one is a rated R movie, and the bottom one is a very rated R movie. Well, whatever the stuff on top gets canceled out by the stuff on the bottom, and there's 2 of the x's left over on the bottom, so it's 1 over x times x, or x to the negative 2. So that's the same deal. What I was asking you is, I multiplied out all the numbers. Now, what is 10 to the 9 times 10 to the negative 6 times 10 to the negative 6? And I can do that because of the commutative property. where I can move stuff around when everything is multiplication, and it's just 10 to the negative 3, because you just 9 minus 6 minus 6 is negative 3. So it's 10 to the negative 3, and then you square root that sucker. It's getting uglier by the second. Anyway, whatever. My answer, so it's not 1828, it's 1.828. But I gotta square root that. SQRT. I gotta squirt it. Comes out to 1.35.
1.3661095.
Yeah, alright. He's got a more accurate number because I rounded pretty much everything off.
Yeah, but when you rounded it off, like I still got 1.36 on the
Well, I got 1.35.
I know, because you're using 9.
Yeah. And technically, his answer is correct. He got 1.36, I got 1.35. If you look at how many sig figs they gave you, it looks like they gave you 3 sig figs to begin with in the problem. So therefore, you need to report 3 sig figs. And technically, I would be wrong. So the answer is 1.36. Is this hard?
No, this one is easy.
That one's good.
It's the law. It's
Yeah, all right, let's do another one.
Electrical fields.
Let's talk about the electric field. That one's not
All
bad.
those like new other equations.
All right, let's do it. Let's do it. I'm basically doing your homework for you, but I'm showing you how to do your homework. And for those of you who are missed out on the class and aren't going to watch the archive, which means you don't care because you guys aren't ever going to see this, but you guys got to do this on your own. Hey, come to class. Watch the archives.
It's fun.
Oh, come on, class is kind of fun.
It's fun. I said it was fun. Did I say it was fun?
All right. By the way, what I was saying, Kalena, is what do you think of the STEM class now? I actually kind of like that we're doing it a little bit non-mathy, but we're going to get into a cool programming project that I have worked out for you. What is that for? Oh, let's check out the next one we got to do. Let's look at number 31. That one looks tough. Should we do 31 or 23? Which one do you want to do? We're going to do either 23 or 31.
31's good.
31?
I think number 23, I printed myself.
Okay. Let's look at 31.
284.
What is that?
So 284, right?
Yeah, 284. 31. Find the direction and magnitude of the electric force exerted on that picture over there. What does that say? I can barely
Point
see.
charge Q2.
All right, here. Tell me what the picture is.
Okay, the square.
It's a square. Is it a square with a charge at each?
Yes, charge at each corner.
Okay.
Q2 at the top left.
So it's -2, -3, -4?
No. Q2 at the top left with a charge of minus 2.1 Q.
Yeah, I got it. -2, -3, -4.
Yeah, and then positive 1 at the bottom.
Positive 1. Okay. So what do you want?
I mean, that's in terms of Q.
What are they asking to find?
Find the direction and magnitude of the net electrostatic force exerted on point charge Q2.
Yeah.
And let Q equal 2.4 microcoulombs.
All right. So you want to find Q2, the direction of force on that guy.
Yeah.
Interesting. I would have figured you want to go around and find the charge on the other guy.
And Q
Or the
is
force. So D is equal to this. This is Q. This is Q. Q. Q.
D is
This is
33
all-
centimeters.
23 centimeters.
33.
33 centimeters. So it's 0.33 meters.
33 meters and Q equals positive 2.4 microcoulombs.
2.4 microcoulombs. Do you understand the problem, Kalena? This question looks confusing. I agree, it does kind of look confusing. Fine. Here's what the question is. You got 4 charges. One is positive 2.4 microcoulombs. The next one is negative 4.8 microcoulombs. The next one is negative 7.2 microcoulombs. And the next one is negative, 16, 1, 6, 9.6 microcoulombs. And all I did was I just said, all right, fine. If this is Q1, this is negative twice of that. This is negative 3 times that. Negative 4 times that. That's how they set it up, and they put it on a square. That's the distance. It's spaced. These are all spaced 0.33 meters apart. What's the force on this guy right here? I guess the question you got to ask yourself is like, all right, let's look at the force.
Obviously, we're imposing that.
Let's talk about the force from this guy right here. How is negative 3 pushing on the cube 2?
It's pushing away.
It's pushing to the left, right? How is negative 4 pushing on that thing?
Up and left.
Up and left. And is it pushing it with a bigger arrow or a smaller arrow than the negative 3? It could be a smaller arrow. Even though the charge is bigger.
Because
Well, the charge is bigger,
it's farther away.
but it's further away. I agree.
And
And then how is this one? How is Q1 acting on Q2?
pushing up.
No, it's actually pulling down.
Pulling down.
Why is it pulling down?
Direct charge.
Because the charges are opposites attract. Now I got a question: is it bigger than the force that Q3 was pushing on it, or is it smaller?
Is Q3 the one that has minus 3Q? Or
Yeah, this is negative 3Q.
That's
So this arrow going down should be smaller than this arrow going to the left. Why?
because smaller charge.
Smaller charge, smaller arrow. We cool? So essentially, you want me to add up all of these arrows and figure out where they, and figure out what the overall arrow is.
Yeah.
All right. Let's take a guess. I'm just wondering what your guess is. How do you think this thing is going to go? Is it going to go like this? If I add up all the blue arrows, is it going to look like this one?
No.
What do you think, Kalana? No, how would it? Are you kidding me? That's so dumb. Why would it go way off that way if the forces are pretty much pushing it to the left? I'm thinking it might be something like this. Do you agree?
Maybe a bit more shallow.
Maybe more shallow, but pretty much something like that. Are we cool? I mean, like that makes sense to you? So that's all you got to find. In fact, the way you find it is you can move these vectors around. You can't change their direction or length, but you can stick them together. So basically you have this first arrow, right? And you have the down arrow, and you have the up and to the left arrow,
And that's your
and then my resultant is really just this one right here. And that's all you do, right? But I mean, the hard part about it,
do the calculations.
no, the hard part isn't doing the calculations. I'll do one of the calculations for you, and then the hard part about it, I'll show you what the hard part about it is. Okay. Let me check my phone real quick. Somebody might have called me. I don't want it to be too important. No, it's just a text message. I don't even read text messages. I don't get text message in my plan. Anyway, let's try one. Cool? What's the force? What is the force on that one? What's the length of that arrow right there? All right, so it's just force equals k q1 q2 over r squared. And actually, I don't want q1 and q2. I'm going to have k q2 and q3 over d squared. Why do I have k q2 and q3?
Q2, because those are
Because that's what it is. It's just whatever.
over D squared. which
And why do
is-
I have a d instead of an r?
Because D is what they give you.
Because that's the distance between them. What do you want from me? What more do you want? All right. I'll tell you what. I'm not even going to plug in the numbers. I'll let you do it. But we'll have k times negative 2q times negative 3q divided by d squared. So that would equal to 6k q squared over d squared. Are we cool?
Yeah.
And you plug in what the Q is, you plug in what the D is, and bada bing, bada boom, you have the force between 2 and 3. So maybe I might want to signify that by putting a little subscript over there.
Yeah, 6q squared
But yeah, that's Q squared.
over d squared.
Yeah.
3d squared.
All right, now how would you figure out the force of 1 and 2? Tell me. I'll tell you what. I'll throw it out there. You tell me what the answer is. What is the force between 1 and 2? Don't tell me the numbers. Just kind of tell me what you guys think it might be.
1 and 2.
Between 1 and 2. Write it down. Don't try to do it all in your head.
Oh, you say don't do the numbers.
What I mean is don't plug in 2.4 times 10 to the negative 6 and don't plug in your calculator. Just do what I did.
Oh. That's what you mean.
Yeah, essentially, Kalena, you would do the same thing. You would just plug in different numbers. Instead of using -2 and -3, you would use -2 and +1. So it's essentially -2kq squared over d squared. Right? Are we cool with that?
Yep.
Now, here's the hard part.
Diagonal.
All right, so we know that, in fact, you might even want to specify this. This will be to the left. And this will be down. You know that just by looking at the picture. Right? Now the hard part is going to be the diagonal. It's going to be hard for two different reasons. It's not that hard, but it's going to be F24. That's going to be K -2Q times -4Q divided by R squared. But is that R simply D?
No, it's like what, D squared over 2.
No, I'm asking Glenn actually. Is R D? Is R equal to D? Because before R was equal to D.
There's Q 2Q 4.
Yeah, we're talking about we're talking about this diagonal force right here, the one going between this one and this one. And the answer is no, it's not, because the distance that we're talking about is this distance right here. Right? The distance that's separating them. And that's not D, that's not 0.33 meters. This is D. I have a question for you. Is it longer or shorter than D? It's longer, right? That makes sense. All right, good. How would you figure that out? Do you know?
Special triangles.
Special triangles, Pythagorean theorem, a squared plus b squared equals c squared. You're looking for the hypotenuse here. But in essence, I mean, it's really just d squared plus d squared equals r squared, I guess. Right? So 2d squared equals r squared. Oh shoot, you just plug this in with a 2d squared. That's it. If r squared is the same as 2d squared, you just throw that in.
It's not d squared 2.
D squared over 2, what do you mean?
I learned in like trigonometry that if you have a right triangle, then it's an isosceles triangle. You just add a square root 2 at the end for hypotenuse.
Now here's what you're thinking. Here's what you're thinking. All right. Victor, what you're thinking is you want to figure out what is the length of r. That's what you're thinking in your head, and you're saying, oh, okay. Well, you would square root both sides because you want to figure out what r is by itself. And then, yes, of course, you would have a square root of 2 times d equals r. I agree with you. But I wasn't looking for just r.
You're looking for...
I was looking for r squared. Or I guess if you want, you can plug in this r into r squared, and then you have to square it out, then it'd just be 2d squared.
Yeah.
Does that make sense? Does that make sense to you, Kalana? All right. Anyway, let's figure out these numbers. This is what? 4 k q squared over d squared. Cool. I'm solving this whole problem without plugging in a single number.
Yeah.
All right.
4 is this 8?
Well, it's 2 times 4 divided by 2.
Oh.
So that's 4. And it's a negative and negative, and that's it. So it's just 4.
4kq squared.
Yeah, no, I feel like this is kind of cool.
D squared. Ah. So what is this?
All right, but here's the deal, yo, is... All right, so, and then which direction is this guy going in?
Up left. Diagonally
Up, left. Are we cool?
Yep.
Is he going exactly up and to the left? Like, describe him in further detail. What do you mean up and to the left? There's lots of up and to the left I can go.
45 degrees.
You think that's 45 degrees? What do you think, Kalena? You think that this angle is 45 degrees? Why? Why do you think that?
Because in a perfect world, you would be pushing it straight. And since it's a square, it's 45 degrees.
We can't say just, yes, I like that. Because it's a square. If it's a square, you're breaking it up into 45 degrees. If this thing were a rectangle, then you would have to use some trigonometry to figure out the angle. And that's a little bit hairier, but equally doable. Right?
Yeah.
But I mean, just by looking at it, you could say, hey, that's probably 45 degrees. Are we cool with that so far? Now here's the hard part. I know that when I add up all the horizontal stuff, I really just have to take this into account. And a little bit of this. And when I add up all the vertical stuff, I really just have to take this into account.
Yeah.
And a little bit of this. But the question is, how much of this do I have to take into account? And how much of this do I have to take into account for the vertical stuff? You see what I mean? Like, we're not done yet. We're not even out of the woods. And I know you guys are thinking that, like, oh, this is such a long problem. Yeah, this is a long problem. But do you really feel like a lot of the stuff, the stuff in this problem was really hard? Not really. It's just a long problem. All right, fine. Just do it. You know what I mean? When you build a bridge as an engineer, there's going to be a lot of calculations you have to do. As long as you get it, it's just a matter of work. And what's nice about it is you get paid either way. And if you get paid by the hour, which you wouldn't as an engineer, you would get a salary. But if you get paid by the hour, hey, you guys want to pay me for doing more work? Fine. I'll do it. You know what I mean? All right, anyway. The question is, how much of this do I account for the horizontal and how much do I account for the vertical? In order to do that, you would use trigonometry, SOHCAHTOA, and I would break this vector into their components. Did I just speak crazy to you, or do you understand what I said? Please say that you understand what I said, especially you, Kalena. Actually, you, Victor, because I didn't. All right, good.
Yeah, I pretty much understand.
So, if the magnitude of this arrow is 4 kq squared over d squared, the question I'm asking you is, what is the length of this one, and what is the length of this one? This would be my fx, and this would be my fy. My angle theta is this. I'll tell you what. I'm going to ask you what fx is, and then I'm just going to, and then after I feel like you get it, I'm going to back off and just say, all right, cool, I think you get it. What is fx equal to?
Cosine. Theta. No, wait.
Just cosine of theta? Which trig function would I use, Kalena? No, don't do the arc cosine. All right, Kalena, you got 3 choices. You got sine theta, you got cosine theta, and you got tangent of theta. Which one would you use? Cosine of theta. Very good. Because we're talking about the adjacent side, that's the one we want to find. We know the hypotenuse. So COTA is cosine of theta equals adjacent over hypotenuse. So therefore I would say cosine of theta is equal to fx over f. And therefore fx is equal to f cosine theta.
F cosine theta.
Yeah.
Oh,
So it's just
okay. F
this thing.
F being 4kq squared over d squared.
Yeah, the force is kq or 4kq squared over d squared. And then if you actually want to figure out what the actual number is, you would plug in what the k and the q and the d is. But actually, you know what? To be honest with you, I wouldn't even plug it in yet. I'd just save that. I'd save that for the end.
At the end.
Whoa, whoa! Did my desktop just stop sharing with you?
Please don't crash. Crash to desktop.
My
Brilliant.
thing crashed. Cause look, I'm not even signed in over there.
I. Very good.
Oh, the internet just crashed.
Really?
Well, the Wi-Fi crashed.
No. Wait. Maybe I don't know.
All right, I'll tell you what. Kalena, the Wi-Fi crashed. I can't really do anything about that. The wired connection is still up. Why don't we just continue to talk about this problem? Okay, it's going to get a little harder because I didn't really do that anything yet. Anyway, all you got to do is plug in your force times the cosine of 45 degrees. So make sure your calculator's in degrees mode and you plug in cosine of 45. We cool?
So basically, once you get all your Fy, Fx, you just add all your values up and then plug
Yeah.
in.
Once you get what Fx is and once you get what Fy is, then all you do is in order to figure out what the resultant is, this force that we were talking about in the end, this big force at the end, is really just you
add add Fy to the down.
Yeah, you add Fy to F12. Does that make sense, Kalena? You add the vertical component of F24 to the F12 because F12 is only vertical. And then you also add well, actually, you wouldn't add them. You would subtract them because they're going in different directions.
Oh yeah.
Right? Fy is going to be going up,
Oh yeah, you subtract them.
and F12 is going to be going down, so you would subtract those two.
And then for Fx and Q1, Q2.
And then for
Q2, Q3.
right, for Fx and for
Q2.
force Q23, you would add those together and make sure that you understand that that's basically just going to the left.
Let's stick them together.
So maybe what you could say is you would say negative FQ23 equals negative Fx.
And then you just stick those together in a triangle and find your hypotenuse.
Yep. Stick it in a triangle, find your hypotenuse, and that's your force in between them.
Brilliant.
So I don't feel like this is really hard, and you know what? To be honest with you, all right, it is hard. It is hard, and you know what? Stop me from saying that. That's a jerk move from my part. If I tell you, oh, this isn't that hard, then it makes you feel dumb when you don't get it. Look, it's not hard if you spent physics 1A with me. Because if you spent physics 1A with me, all we would be doing is this stuff. This is what we've been doing all the time. This is your first experience with this. This is your first experience with this, so you won't be doing this all the time. But I'll tell you what, if you guys want to be an engineer or a physicist, like go into physics or even math, this is kind of an important concept. So if you learn it well now, you're going to kill your other classes, your other science courses. You got it? I feel like it makes sense. I feel like I did a pretty good job explaining it in a way that made sense to you. All right, I'll tell you what.
Wi-Fi works. I think it's just your computer.
The Wi-Fi does work?
Wi-Fi does work.
All right, well, my computer just crashed out on me. I've got 6 more minutes in the class. Why don't you guys do those 2 problem sets? Out of the 5 problems that are due today, I did 2 of them for you. I didn't finish them. I didn't plug in the numbers. I didn't calculate it out. Actually, I think for the first one I did plug in the numbers. But at least you have a head start on that. And after doing them, I think that they're very reasonable.
They may be long and tedious, but it's reasonable.
We got it? We cool? We happy? Talk to you later.